Things to know when it comes to testing. This is going to be more of a cheat sheet. There's not going to be any coding examples, just a list of things to know. The first thing is the importance of testing. It's much cheaper to fix a bug earlier detected. Second thing is that testing or a test suite is much more repeatable. You only have to write your tests once and then reuse them at the click of a button. As the code base grows and maybe there are a lot more developers in your team, it becomes the only way to really catch a bug that appears elsewhere if there's something else that's being broken. Next up is a test pyramid, different types of tests from unit all the way to end-to-end tests. So unit tests are meant to be the quickest and maybe they test only one functionality, for example, just one method, whereas an end-to-end would run through the whole system. So in practical terms, ideally you should have a lot more unit tests and then finally maybe have fewer end-to-end tests as they are a little bit more expensive to maintain. Test-driven development, also known as TDD. This is the practice of writing your test code before you actually do the method. It forces you to think long and hard about what this method is going to be doing. So in a way, it acts as a specification, a list of almost like a standard that your method is going to have to meet. The process is typically known as red-green refactor. So you start off with a failing test. This is to ensure that your test is actually valid. So it didn't just pass by accident or pass by chance. Next up is a number of testing frameworks. .NET typically comes with a built-in MsTest framework. There's also Nunit. The most common one is xUnit. Other packages to include when you're doing a testing would be Fluent Assertions and also Autofixture. Autofixture helps in creating a number of test dummy data, so you don't have to manually do this yourself. Another concept is that of dependency. A dependency would be any module functionality or anything that's maybe external to your little unit or your method. So for example, if you are connecting to let's say a financial services provider, you might have an API service calling into it, or if you're using a weather service that provides weather forecast, it might be expensive doing every call into that service. So the easiest thing would be maybe to do a fake, write your own fake, or to use a mocking framework. Some of the popular mocking frameworks are mock and substitute. Test coverage, typically it's just an indication of how much of your code is covered by tests. These are very good at showing you where you're still missing tests, but they might not be very good at indicating the quality of each test. So for example, you might just have a lot of tests, or let's say 100% code coverage, but most of those tests are only testing trivial code. Overall, in terms of just getting started with testing, it's actually very easy. But when it comes to managing a lot of tests, you might need some kind of advanced thinking or maybe shift gears a little bit. A couple of mindset shift or maybe some of the common phrases to keep in mind would be Brownfield versus Greenfield. Brownfield is if you have an existing code base that might be maybe a legacy system or maybe even a code base that didn't have a lot of tests. So this might be somewhat a bit more difficult versus if you are starting from scratch, Greenfield. So you can then implement a lot of the best practices just from the get-go. Testable code is another thing to keep in mind. How easy is it for you to write tests against the code base? A test suite, this is just pretty much everything to do with the test. That would be the integration, the unit tests, as well as the dummy data. And then treating your test as a first-class citizen, meaning just in the same way that you want to maintain your code and make it more efficient or refactor it or cut out items that you're not frequently using. The same thing needs to apply. The same kind of mindset needs to apply to your test suite. And then the idea of a brittle test, sometimes or most of the times you're expected to make changes to your production code. Any change that you make that breaks a lot of the test cases, that's typically referred to as being a brittle test. So the main concept here is having code that's testable. This can only be achieved if you've written your code in a best practices way. For example, using solid principles. Most important principle to take away from solid might be single responsibility as an example. So you have a method that only does one thing, or a method that is small. You've intentionally made it small so that it, not for the sake of testing, but it's very clear as to what this method is doing. So it's got a very clear specification and a very clear outcome. Another thing that makes code a little bit more testable would be clean architecture. Clean architecture typically separates out your dependencies or your external API calls or calls to the database. It separates them out from your core logic or your core domain. As we move on, mocking. If you find that you have a lot of mocking in your tests, it might be a code smell or an indication that your architecture is not quite right or that you're blurring a lot of the integration and unit tests. So the problem here is that because the test suite is going to keep on growing, you need a lot of your tests to actually be valuable. So they need to be they need to be pointing you to a problem. It's also very expensive to maintain this code. So it might be more efficient to just have integration tests that are not mocked. They actually call into the dependency or the interface, or to have unit tests that are actually just testing one thing. Amongst a lot of developers, there isn't really a clear definition. There's no consensus as to what a unit test is. My definition would be that a unit test should be focused only on the core logic or the domain. So there shouldn't be any calls to the database. There shouldn't be any API or external items. Therefore, within a unit test, you shouldn't be having any mocking. Also, no interfaces or no dependencies. So it's actually just a lot easier to run this unit test. There's not any complex setup that you're going to need. And then if we have a definition of a unit test, an integration test, like I've said before, it would be you have to be testing your actual dependencies. So it's the closest thing that you're going to get to an end-to-end test. The last bit of advanced concept would be having a test that is an abstraction. So now the problem repeated or stated before is that you don't want new functionality or new code to be breaking your test, which is called having test as brittle. And then another challenge might be if you've got too much setup, if you need to get just one simple test, but you have to do a lot of setup, you have to call into a lot of dependencies. Also, if you have a lot of code that's repeating within your tests, you no longer have one unit test, you've got maybe 100, 500, however many. The concept of dry versus damp. Dry to not repeat yourself. So dry is more applicable to your production code, whereas damp, maybe you might have some repetition. The aim of damp is to have your testing code a little bit more descriptive or a little bit more understandable. To achieve this, you're going to need an abstraction layer, some kind of test context wrapping around all the setups or anything to do with your testing. So by testing against an abstraction layer, a lot of these problems are sort of reduced. So that's pretty much it. The quick cheat sheet again. The basic checklist would be that it's important to have tests in your system, especially if you're going to have a growing code base or you have a lot of developers. You have to really understand the test pyramid, especially the value of unit tests. You can actually get away with only having unit tests and without having to have the more expensive end-to-end test. You should consider using xUnit. All the other testing frameworks are also okay. xUnit is more common. And then in terms of just getting started, you're going to run into the problem of having a large test suite. You might need more advanced concepts, such as that your code has to be testable. Have a look at the testing pyramid again, that your unit tests have got to be separate from your integration tests, and as much as possible try and avoid mocking, and then simply create an abstraction or a test context. Things to know when it comes to testing.